Okay, thank you for watching this video. Before I start, I ask you please subscribe to my channel and try to watch my videos online. Let me continue on solving some more problems in numerical analysis. Let me state the problem. Let f of t be a polynomial of third degree. Show that. I want to show that f of x, y, and z, in fact the divided difference, I mean by f brace x, y, and z, it is equal to half f double prime at x plus y plus z over 3. This is the problem. I want to show, in fact, this equality. We have to note that x, y, and z are distinct. And let me just state this one, x, y, and z are distinct. Okay, now let me try to solve the problem. Consider u as a new point, okay, which is distinct with x, y, and z. So let me start by let u be a new point distinct with x, y, and z. Okay, so if we consider p of t, okay, so p of t of third degree, interpolate f of t at x, y, z, and let me consider this one w, maybe much better, and let me fix this one, a new point, and w. Okay, yeah, and it is, so in fact I can write f of t is exactly equal to p of t, because we know that f is of third degree and p also is of third degree, so p interpolate f exact. Okay, so f of t equal to p of t, and this is equal to f of x plus times t minus x times f at x and y plus t minus x times t minus y times f double prime at x, y, and z plus t minus x times t minus y times t minus z times f triple prime of x, y, z, and w. This is by the Newton interpolating formula. Now, let me simplify these relations. So it will be f of x plus t minus x times f x and y, okay, it is correct, plus, and here you multiply these two parentheses. Okay, so it will be t squared minus x plus yt plus xy times f double prime at x, y, and z. And finally, for this one, we multiply these three parentheses to get t cubed minus x plus y plus z t squared plus xyt minus xyz minus xyz, yeah, times f triple prime x, y, z, and w. Now, take second derivative from both sides. Why we have to take second derivative? It's because in here we need f double prime at this point. Okay, so take second derivative. So I will get f double prime, it is equal to 2t times f double prime x, y, and z. F double prime, of course, with respect to t, right? This is to this form. And from this one, if we take the second derivative, it will be 3. And now 6t plus 2 times x plus y plus z, and it should be, of course, minus, not plus. Here, minus 2 of this one, okay, times f, x, y, z, and w, and of course something wrong here about here and here, of course. These are not correct. Now it is fixed. Okay. Right. Now we set t equal to x plus y plus z over 3. Right? So what we get? We get f double prime at x plus y plus z over 3 is equal to, and maybe was something again wrong here, and this is just 2. Lots of miss. Right, okay. F double prime of t is 2f, and now it's correct. Okay, now put f to f, x, y, and z, and also this term, if I consider t equal to x plus y plus z over 3, this term vanishes. Okay, so it is plus 0. And this gives f at x, y, and z is equal to 1 over 2 f double prime x plus y plus z over 3, and this completes the proof of the problem. It was easy, it's not so difficult to solve. Just a little, you have to be careful when you multiply the parentheses and when you take derivative. So just please subscribe to my channel and wait for the next lecture.